Okay, we're going to talk about finding limits numerically, and by numerically we mean that we're talking about looking at a table of values. Sometimes when we're dealing with limits, we are not given a function equation to work with, and we're not given a graph, a picture of the function to work with, but we still want to know what's happening to our output values, our y values, as our input x values approach a certain number. So if we look at the table that I've got above, I want to know what's happening as I get closer and closer and closer to 3 for x. My input gets closer to 3. So I notice in my table I actually have a numeric value for the function at 3. That's immaterial. It doesn't really matter what happens right at 3. What matters is what happens as I approach 3 from both the left-hand side and the right-hand side. So we talked about limits, and I would write the limit as x approaches 3 from the left-hand side of this function. I don't have an equation, so I'm just going to use f of x. But I'm going to look at my picture. And as I start at 2.9, when my 2.9 is x, I get 6.7 for y. When 2.99 is x, I get 6.97 for y. When 2.999 is x, I get 6.997. It should be pretty clear what's happening. As my x values get really, really close to 3, my y values are getting really, really close to 7. I'm going to do the same thing on the other side. I'm going to ask what happens to my function as I approach 3 from the right-hand side. So now I'm going to start at 3.1, and at 3.1, my y value is 7.3. At 3.01, my y value is 7.03. At 3.001, and getting closer, closer, closer to 3, my y value is 7.003. So once again, it appears that my limit is approaching 7. Because the limit on the left-hand side and the limit on the right-hand side approach the same number, we say that the actual limit of this function as x approaches 3, notice we don't have any minus or pluses to say either side. This means we're looking at it from both sides, and in this case, the limit is 7. Okay, so once again, we have a table of values, and this time I want to know what is happening to my function, my y or my f of x, as my x approaches 2. And I notice that in my table, it says that my y is undefined. It does not exist at 2. That's not a problem. I just want to know what's happening as I get really, really close to 2 from the left-hand side and as I get really, really close to 2 from the right-hand side. So I'm going to check out what the limit as x goes to 2 from the left-hand side of whatever this function is by looking at my table. Well, when I look at the left-hand side, I'm going to ask myself, okay, so what's happening to my numbers? At x is 1.9, I get 8.6 for my output. At x is 1.99, I get 8.96. At 1.999, I get 8.996. It should be pretty clear that as my x's get really, really, really close to 2, my y's seem to be approaching the number 9. And so my limit is 9. I'm going to do the same thing from the right-hand side. I'm going to ask myself, as I approach 2 from the right-hand side, what's happening to my function? So once again, I'm going to start at 2.1. I'm at 9.4. At 2.01, my y is 9.04. At 2.001, I'm at 9.004. Once again, it should be pretty clear that as I get really, really close to 2 on the right-hand side, my limit is approaching 9. So once again, we can say that the limit as x approaches 2 of this function, whatever it is 9. Now, this function does not have a function value at 2. It's undefined. There is no value at 2, but it can still have a limit at 2. Now, it's not always the case that when you approach a particular number from the left and you approach a particular number from right, you get the same answer. Sometimes you actually get different answers. And when that happens, you could have a left-hand limit approaching one number, and you can have a right-hand limit approaching some number, but if the two numbers do not match, then there is no limit at that particular number. So in this problem, when we started out and we said the limit from the left-hand side came out to 9 and the limit from the right-hand side came out to 9, so the limit, without the little plus or minus, is 9. It tells me that there actually is a limit at 2, and that limit is 9. And again, it doesn't matter that I don't have a function value at 2. All right, so let's try a harder one in the next page. Okay, now we've got one more table. And I want to know what's happening as I approach 8 from the left and the right. Again, as I look at my limit expression, if the limit when I approach 8 from the left-hand side is the same value as the limit when I approach 8 from the right-hand side, then the limit at 8 will be that same number. So I'm going to identify 8 in my chart, and I notice that it's undefined at 8. There is no function value for 8. Again, that's not a problem. I'm not asking what's happening at 8. I'm asking what's happening as I get really close to 8, both from the left and the right-hand side. Well, this one's a lot different than the last one. This one starts out at 7.9, I'm at 3.9. At 7.99, I'm at 78. At 7.99, I'm at 150. Wow! As I get really, really close to my 8, my x value gets really, it could be 7.99999. What's happening to my y? It's getting really, really huge. In fact, it's approaching positive infinity. That means I'm going to have an asymptote. If I take a look at 8.1 from the right-hand side and start approaching, I notice I'm at -3. At 8.01, I'm at -400. At 8.001, I'm at -700. This one looks like it's approaching negative infinity. Well, I'm not approaching the same thing. In fact, I know there's an issue at 8. It was undefined. This is clearly an asymptote because from the left, the picture is going to head upward to positive infinity, and from the right, the picture is going to head down to negative infinity. So if I had a little slight graph here, and here's 8, I know there's an asymptote going on here. As I get really close to 8, this is going upward, and I get really close to 8 on this side, it's going downward. They're not going the same direction. They're not even going to a number. So we say that the limit at 8 does not exist. Okay, hopefully you can look at tables and decide limits from the left and the right.